So, so this will be for chapter 4, which is comparing different distributions. This is really picking right up from chapter 2, where we learned how to look at categorical data, how to graph it, how to look at quantitative data, and how to graph that, and different things we can tell about it. We're going to continue with the quantitative data, and now we're going to look at some ways that we can do comparisons and break things down a little bit differently, or compare different groups, as the case may be. So I've pretty much typed everything out on this one because there's only a little bit of math at the very end. So I thought it would be easier if we just kind of write this out beforehand and we can just kind of go through it. And I'll point out some things that are not explicitly written on here and explain why we're saying what we're saying. So if we look at number 1, wind speeds in a forest, we have the histogram here, we have the box plot for the data underneath, we have the 5-number summary. So all of this is stuff that we talked about in the last chapter. And so you can see it says unimodal. So if you remember, unimodal is the mode is the highest bin in the histogram. So we only have one mode. Most days would be less than 1 mile per hour. So we see the 2 tallest bins there. Skewed right, the long tail is coming to the right. Median, and for this you'd have to go to the summary there, 1.12, and then IQR is 1.82. And if you remember from the previous chapter, IQR is Q3 minus Q1. So that would be the 2.28 minus 0.46. That gives us the 1.82. Possible outliers. So definitely these would likely be outliers out here. Doesn't look like there's more than 1 or 2, but maybe even these 2 might be outliers as well. We said last time that a gap in histogram typically indicates outliers, but you could also have some over here too. So we're kind of getting, we're pretty far from the median and the third quartile. Third quartile would be right around here, or even right around here, I guess. So getting out here, we're getting pretty far from most of the data. So those could be outliers. And then one very windy day, which would be that one. So that's just kind of the things. Most of the things in this chapter are just kind of observational. You need to be familiar with the terminology and how to look at the histogram, and then the rest is just kind of observation. So nothing too complex here. So number 2, now we have the same data, but it's going to be broken down into 2 sets. We'll have summer months and winter months. And so just things you can notice: the summer is unimodal, skewed right. The winter is not very skewed at all. We might say we have a longer tail over this way, but not too much. And then it's also pretty uniform. This one is the tallest, but it's not much taller than any of the others. So I wouldn't even necessarily call that a mode. Typical summer wind, less than 1 mile per hour. We have a few days up here above 3 miles per hour. The winter, we really have to go up to 3 miles an hour before we get to most of the data, and more spread out. So the range coming all the way up to over at least 4 before we start to really drop off up here. With summer months, really everything's below 1. Maybe you could go up to 2. Relatively calm in the summer. Winter has windier days. Standard deviation and IQR, so if we look over here, show that the winter wind speeds are more variable. So the higher the standard deviation and the higher the IQR, the more spread out the data, if you remember from last time. So standard deviation, as you recall, is the average distance from the data points are from the mean. So the more spread out, the higher the standard deviation will be. All right, moving along to number 3. Now we have what's called so we talked about stem and leaf graphs last time. And now we're going to look at a back-to-back stem and leaf. And so these work the same way. You have to be a little bit careful with how you read them. So again, you'll always have a key or legend under here that tells you how to read this. So 4/9/3 means 94 for the left group and then 93 for the right group. So in this case, the middle column, when you have a back-to-back stem and leaf, the middle column will be your tens digit or whatever the left digit is. So back-to-back stem and leaf compares nest egg indices. Back-to-back charts are best for comparisons. 5, 8 on the left. So if we look over here, 5, 8, that is 85%. So this row would be 85%, 87%, 87%, 88%. So again, make sure you understand how to read these, because if you don't know how to read the chart, then there's not much you can do with it. Northeast and Midwest generally have bigger nest egg indices than South and West. Now, one complaint I have about this chart, just kind of as an aside, is typically when you have a vertical axis, you have the lower numbers at the bottom and the bigger numbers at the top. But in this case, they're reversed. You have the lower numbers at the bottom, or lower numbers at the top, and the bigger numbers at the bottom. So these here are actually higher than these over here. And I mean, it's obvious if you pay attention, but it's not, I don't think it's typical that you write it that way. So I'm not sure why it's presented that way, but it is. Then we have Northeast and Midwest, most values above 100. So here would be your 100, 101, 102, etc. A low of 93, high of 114. And then 9 Northeast and Midwest states have higher indices than any of the states in the South and West. So the highest in the South and West would be 106, and then we have 107 over here, 107, 109, and then 111, 112, 112, 114, 114, 114. So 9 of those that are completely above the the South and the West. All right. So the 5-number summary, we have, this is just kind of a numerical way to quickly summarize data. We can tell a lot about when we just had the 5-number summary. And it is comprised of the max value, the third quartile, the median, first quartile, and minimum value. So if you ever see a chart or a table where you just have 5 numbers, it's typically safe to assume that it's just a 5-number summary and not a data set. I mean, I guess it could be a data set, but it's probably the 5-number summary. So this is going back to the wind example that we had at the beginning. So the IQR we could find by subtracting Q1 from Q3. 25% of the days were less than 0.46, and 25% of the days were more than 2.28. And then we had one extraordinary high day of 6.73. And then from the 5-number summary, we will get box plots. And the box plot is a graphical way to show the 5-number summary. So what we have here, so this is a box plot of the wind speeds. And so we'll just kind of, actually, we can write this out. So this middle line in the box is the median. The top of the box is going to be your Q3. The bottom of the box is going to be your Q1. And so the box itself indicates the middle 50%. And as it says here, the height of the box is equal to the IQR. So whatever that length of that box is, that would be the IQR. If median is roughly centered, then the middle half of the data is roughly symmetric. So meaning if this median line is in the middle of the box, then the median is halfway between Q3 and Q1. So at least that part of the data is symmetric. If the median is not centered in the box, then the distribution is skewed. The whiskers, so that's talking about these lines coming out from the box, show skewness if they are not roughly the same length. So we can see here, this one is very short, this one is very long, and we'll talk about how to find those a little bit later. Possible outliers displayed individually. So anything outside these whiskers would be outliers. And so since this is so far skewed this way, we're not going to have any outliers this way. all the outliers, if there are any, would be up here. Possible outliers displayed individually. Outlier nomination rule is not a definition, so it is possible, and it kind of depends on how spread out your data are. If your data is very close together, you still could have one that might be considered an outlier, but if they're close together, it doesn't have to be that far away to be an outlier or to be a possible outlier. So you may not consider it based on, it's all relative to how spread out your data are, generally speaking. But these are guidelines, and we'll talk about rules for where we set these, and then we can talk about if they actually are outliers or not. The central box contains days with wind speeds between Q1 and Q3. Long upper whisker indicates distribution is stretched out at the upper end, which we saw in the histogram. It was skewed right because it has a long tail coming down as we get higher. A few very windy days, which we can see up here. All right, and so box plots are a good way to compare two data sets. So, so we can see box plots have an ideal balance of information and simplicity. They're very simple to make. Even by hand, you can make a box plot pretty easily and pretty accurately, at least for comparing two different things. We're hiding the detail and displaying the overall summary. It's good to do side-by-side comparisons. We can easily see which group has the higher median. That would just be the line in the middle of the box. We can look at the boxes and see which one has the greater IQR and which have the greater overall range. So box plots are very useful, and you can see here we've broken down the wind data by month. And so it's very easy to see which have the wide ranges, which have the lower overall wind speeds on average, and then where the outliers are, where the minimums are, and that kind of thing. So it's very easy to compare. Whereas if you just had numbers for each month, it wouldn't be, I mean, you can obviously tell, but it's not visually as easy to tell. So the box plots are very, very easy to read and see patterns and what the trends are. All right, so another example, and we'll compare these box plots. We have steel roller coasters and wooden roller coasters. So the median for steel is a bit higher. It might actually be, it's probably about the same. Actually, we could probably say it's the same. So the median is this middle line. It's about the same for both. IQR for steel is slightly more than the wood. You can see the box here is a little bit longer than the box here. And you can also see, I didn't write this part down, but the median here is pretty central between the quartiles here. The median is much closer on the lower end. And then steel has a much greater range, going all the way from just barely above 0 all the way up to 150. So, and then the wood goes from probably 40 something to 70-ish. All right, so again, box plots are very useful for summarizing data. They're very useful for quickly seeing where groups compare to each other. So, all right, number 5. So here's another comparison of box plots, and we have the 5 number summaries. So we want to compare which of 4 different coffee cups keeps the coffee hot. Measure the temperature 30 minutes after being poured for each of the 4 types. Repeat the experiment 8 times. So each of these types of cups have 8 data points. And one thing to pay attention to in this case, notice the y-axis is temperature change. And if you're a coffee drinker, you know that you don't want your coffee temperature changing a lot. So you want to be able to, if you don't drink it immediately, you want it to still be warm whenever you get around to drinking it. So, so in this case, the lower values would be better. So that the lower values means the temperature change was small, so it stayed hot. So individual cup types are slightly skewed to the high end. So we had the median on all of these is closer to the low end, so that means it's skewed that way. So skewed right if you did this horizontally. Nissan is best for keeping coffee hot, typically losing only 2 degrees. So there's your median, it's right around 2. SIG is the worst, typically losing around 14. difference is large enough to be important. So especially between the best one and the worst one, median of 14, median of 2. I mean, that's pretty relatively big difference. And the Nissan IQR is also the smallest, so it has the smallest box. All right, so let's talk about outliers. How do we find these whiskers or fences, as it were? And what do you do with outliers? So maybe I should have reversed this, but we'll do this first. How to approach outliers. So check to see if there maybe have been an error in the data collection or data input. So if the reported heights of students include a student that is 170 inches tall, that would be 14 feet. Maybe that student was measured in centimeters. So it's possible that there could be a units error, or possibly digits were switched, possibly decimal is in the wrong spot or something like that. So any error like that could cause there to seem to be an outlier, in which case you would need to correct that. Check to see if there is an extraordinary outcome. The median number of daily customers at the Puxatawny, Pennsylvania gift shop may be 42 with an IQR of 12, but on February 2nd, there were 831 customers. So that was just an extraordinarily busy day. That would be a true outlier. But if you're looking at, an average day, you might want to exclude that point because that's, extremely out of the ordinary. So just things to consider with outliers. Depending on the outlier and depending on what happened, you may pay attention to it, you may eliminate it, you may just count it with everything else. So it just depends. It just depends. And so now we kind of get to the only really calculating part of this. And this is no big deal at all. So calculating fences for the box plot. So where do you set the boundaries for where the outliers might be? So we call these fences. We have an upper fence to be in the top part of the data, and lower fence in the bottom part of the data. So upper fences and lower fences are used to decide if any data points could be outliers. Any points outside the fences will be considered as potential outliers. So our formula, first we're going to use IQR. So just a reminder again, the IQR is Q3 minus Q1. So we have an upper fence, and we will need to find the lower fence. And these are probably formulas that you should memorize. They're not too hard to memorize once you use it a few times. It's nothing too complex. So the upper fence is going to be Q3 plus 1.5 times the IQR. And then the lower fence is Q1 minus 1.5 times the IQR. So very simple formula. You just plug it in and you can get your fences. So we have a data set here, and this is the 5-number summary. We want to calculate the upper and lower fences to see if there are any potential outliers. So let's first find the IQR. So the IQR is Q3 minus Q1, so 21 minus 9, which is 12. And then we're going to find the upper fence and the lower fence. So Q3 plus 1.5 times the IQR. And so if my math is correct, 21 plus 18, that would be 39. And then the lower fence would be Q1, which is 9, minus 1.5 times IQR, which is 12. And so 9 minus 18 would be negative 9. So the way to kind of think about this pretty easily is you can put your fences on a number line and kind of close them in parentheses like that. Anything out, so we're closing in the non-outliers. Anything outside the fences is an outlier or an outsider, you could say. So do we have any data points? So well, 5 would be somewhere around here. 29, which is the max, would be somewhere around there. So both of those are inside the fences. So they're not outliers. And there's nothing beyond those, so there could be no outliers. A potential outlier, if you had a data point that was 45, say. 45 would be an outlier if it was a data point, or negative 15 or anything beyond that would also be an outlier. So that's how you decide that. Very simple. If you have trouble remembering or figuring out if this point is on the correct side or the incorrect side or outlier side or non-outlier side, just draw this little number line, put your fences, put parentheses to close everything in. Anything outside that would be an outlier or a potential outlier. So, all right. So there's that chapter. I don't think too difficult as long as you kind of understand the terminology. I think most of the problems on this chapter are multiple choice, so should be fairly good to go. But if you have any questions, you're welcome to email me and I will handle those.